is on EasyBuild and Spack. And here, I'll start with saying that I'm definitely biased here. I've been working on EasyBuild for about 15 years. I've been keeping an eye on Spack for a very long time, but I haven't done much with it hands-on. I did some of it for this training, and I'll actually do it during the demo as well. But if you ask me to pick between these two, it's going to be very easy. Now, I'll try to make it a neutral comparison between these tools, and they're actually quite close to each other in some sense, but very different in other ways. And that's the main thing I'm focusing on here. So what both of these tools solve is that, as you have seen throughout the whole day, there's a wide variety of ways to install software. You can use pip, you can use CMake, you can use a whole bunch of other things. And what you choose typically depends on the software that you're installing, or maybe some aspects about that software, or maybe even the system on which you're installing it, and so on. So things get very complicated, very messy, very quickly. We've learned this very early on when we started working with HPC clusters at Ghent University, and within the VSC, we quickly realized that this was going to be a mess if we wanted to provide a rich software stack, a central software stack. We had to do some tooling around that, and apparently there was no tooling around that at that point, at least. So we're talking 15 years ago. So this is the reason we started EasyBuild at Ghent University, and it quickly was picked up around the world. A couple of years after that, a similar effort was started in the US, which was called Spack. So these tools are solving similar problems, but in a very different way. What they both do is they try to install software from source code. So we're compiling things from C++, from Fortran into binary format. And they do this in a way that they're really paying attention to the performance of those installations. So that's one of the core things that both of these tools do. They also are developed by communities. So a lot of people work together on making sure that the details are correct when you're installing this software, that you're getting good performance, that the software is tested, that it works as it should be, and so on. One thing we definitely do in EasyBuild, and maybe there's a bit less of that going on in Spack, and that will actually pop up during the demo as well. We not only install the software and then assume it works, we also actively check that it works, and that it works correctly. So if the software has a test suite, we also run the test suite and try to make sure we validate the installation that way. All right, so EasyBuild and Spack are quite prominent on HPC clusters. If you talk to anyone managing an HPC cluster, you'll probably hear them saying they use either of these tools, or maybe combine both of these tools together, at least when they're managing a central software stack. So let's start with EasyBuild. I can talk for a full day about EasyBuild. I'm going to do it here. I'll try to keep it to 10 minutes somehow. But EasyBuild is a tool that was created at Ghent University now over 15 years ago, and that after a couple of years of developing it in-house, we also made it an open source tool. It automates the whole installation procedure. So that whole dependency graph that I showed in the beginning for TB Lite, you can essentially use a single EasyBuild command, tell it to install a particular version of TB Lite with a particular compiler toolchain, and tell it to do all the dependencies as well, and it will go off and install everything, essentially the whole dependency graph, down to even the compiler itself as well. It does the software installations. It also generates module files, environment module files. So in the end, you get a module file that you can load with module load to activate the software and start using it. So it actually automates as much as makes sense. Of course, strong focus on scientific software, performance, HPC, that's sort of a given. After a while, so shortly after it was open sourced in 2012, it started being picked up by other HPC sites around the world, first in Europe, but then also broader. And now it's really a worldwide community working together on this tool to try and make it better, add support for more software, and so on. It's used pretty much on all the VSC clusters, so tier 2 across all the sites, and tier 1, but also well beyond that. For example, on Lumi, it's also the tool that they use to manage their central software stack on the Lumi system. They use it in a very particular way, very different from how we use it in the VSC, but it's still the same tool and the same type of mechanism being used. So to start with, if you want to start using EasyBuild, you'll have to install and configure it. EasyBuild itself is a Python package. You can just use pip install to install it. So that's quite easy. As Stephen explained, it's a good idea to do this in a virtual environment, so it's sort of isolated and you're in full control over the installation itself and the dependencies. And one thing that I typically recommend is using also the rich and the archpack optional Python packages. So rich is used to create colors, generate colors in the EasyBuild command line interface, and archpack can be used to detect what type of CPU you have. And based on that, EasyBuild can make some decisions as well. So once it's installed, and I'll show this hands-on in a bit, you should also configure it, because the default that EasyBuild has is to install things in your home directory. To make it even worse, in a hidden .local directory in your home directory. So unless you know where to look, you won't even find the software. This is sort of a standard. It's maybe not a very good standard, but fine. It has been like this for a long time, and at least we're following the standard. You typically see many of these tools using $home, so your home directory, because that's really the only thing that you know will be there on any Linux system. It's hard to come up with a different location that will actually be there. So you should definitely configure EasyBuild, mainly to control where it will install software, but also where it will build software. So where it will do the compilation, you want that to be a fast location. So for example, we do it in a temporary directory, so a local directory on the system, and not on the shared file system like your home directory is. That would make the installation of software a lot slower. So if you don't want to play around too much, what you can do is set the EasyBuild prefix to, for example, a location in VSC data, an EasyBuild subdirectory there, and then set a different location for the EasyBuild build path. So the location for the build directories where it will compile software before it installs stuff. If you only set these two things, you're good enough to go, and it's a lot more sensible to configure EasyBuild that way. So once it's installed and configured, you can start using EasyBuild to install software. EasyBuild works what we call easy config files, so essentially recipes that specify which software should be installed, which version, which toolchain should be used, which dependencies should be used, and which versions of those dependencies. So all of that is specified in an easy config file. EasyBuild comes with over 10,000 easy config files in the installation itself, and you can use the search option to figure out what it has. Once you have a particular easy config file, you can check which dependencies are still missing with the -- missing option. Or with -x, which we call extended dry run, you can ask EasyBuild what it will do to perform the installation without it actually doing anything at all. So you can get a pretty quick overview of what will actually happen before it does something. If you're happy with what you're seeing, you can just tell the eb command, use this easy config file to do the installation, and you can enable the robot mode so it also does the dependencies that are still missing. If it all works out, which I will hopefully show with TB Lite in a bit, you can make sure that the module that was generated is available. So you have to extend the module path for that with the module use command. And then you can load that module and it should work as you expect it to be. Now, one thing that's interesting to mention here, and which will also happen in the demo, is that any modules that are already available, EasyBuild will just use. If it sees a module for the toolchain or for a particular dependency, it will just do module load, and that dependency will become available. So it doesn't have to reinstall everything if some modules are already provided. Okay, before we go to Spack, let me do a quick demo with EasyBuild. And let me check which situation we're in here, because I was preparing a bit. So in here, yeah, we already have a virtual environment, so I'll just remove this and start over, which takes some time because this has a lot of small files. All right. So I'll start with the installation of EasyBuild itself. I'll create a directory in which we'll create a virtual environment. We'll activate that virtual environment, do a pip install in there. I'll actually install Rich as well, so you at least get some colors, and then we'll make sure that EasyBuild works. So let's do that. Creating the virtual environment, activating it, and then pip install EasyBuild along with Rich. So this should only take a couple of seconds. So EasyBuild is split up into 3 separate Python packages, which is really a detail here. And the big one here is the easyconfigs package. This has over 10,000 easyconfig files, and that EasyBuild comes with. In a couple of seconds, this will complete, and you should be able to run eb-version. All right, so this is the latest version of EasyBuild. We can now check if it knows about TB Lite, which it will. It actually has a couple of options for that. Let me use this short search option, which looks a bit nicer. So this is the one we'll try and install. Before I do that, I will make sure that EasyBuild is properly configured. So I'll check with show config what the current active configuration is. And here you can see it's abusing the .local subdirectory in my home directory, which is not a good idea. So I'll go back and copy paste this minimal configuration here. Just setting two environment variables, EasyBuild prefix and EasyBuild build path. If I now run show config again, you'll see that things have changed. This is now the location where it will install. And this is the location for the build directories, for example. I'll actually change it a little bit more because I want to make sure this is doing installations for our current operating system and our current CPU. So if I check the value of this environment variable, we're on an Intel Cascade Lake system, and I want to make sure I separate those installations from other ones. All right, so that was installing and configuring EasyBuild. We can now install TB Lite. And since the modules that are available in the central software stack are already installed and available in this environment, it will actually refuse to install anything. It will just say TB Lite is already there. It doesn't make sense to reinstall it. So it's now picking up on the TB Lite that's available in the central software stack here. So I'll just convince it to do a rebuild in my own VSC account with the rebuild option, just to show you what this does. So it will now step through the different phases of installing TB Lite, which starts with getting the source tarball. It will pack that tarball. In fact, here also apply a patch file to fix a problem with the TB Lite tests. It will set up the build environment by loading modules, start with running CMake with a whole bunch of options. That's pretty quick. After CMake completes, it also checks on exit codes of commands. So did something actually work? If not, it will give up and try to do some decent error reporting. It's now doing make, so this will take about 20 seconds to run make. And then after the build step, so running make, it will also run the test suite for TB Lite, which will also take a little while. Now, while that's going, we go back to the slides. Once that completes, we'll make sure it actually picks up on the location where the module file was installed for this TB Lite installation, and then we'll try to load it and make sure it works. So here you can see it did the test step. So it ran C-test in about 5 seconds. It's a very lightweight test, but it did work. It completes the installation with make install. And this is mostly about the TB Lite library and the TB Lite command. It then also installs a TB Lite as an extension. So extensions as terminology in EasyBuild for additional Python packages, Perl modules, this type of stuff. So it essentially goes through another cycle of configure, build, install for the Python part. It makes sure that the things that it expects to find, like a binary for TB Lite or a Python package for TB Lite, that's actually available, that pip check is happy. So pip check is to verify whether all dependencies are there. So it does a couple of lightweight checks. And in the end, it completes the installation and it gives us a module file. If we now do a module avail, or sorry, module use on this, and then check again with module avail TB Lite, we should see 2 TB Lite modules. This one that we just installed and the one that's part of the central software stack. Of course, the first one is going to be the one that is loaded. If we do module load, come on. This. Now loading all the dependencies as well, and we can check that the TB Lite command is the one we expect. And the Python script, which we have here, is also working. So we got a working installation of TB Lite, and it's reusing the dependencies that were part of the central software stack. So you can see it's it's relatively easy to use, I guess, and it gives you a lot of details on what's going on in the background, so it doesn't try to hide too many things if you're interested in how things are actually installed. That's a very basic usage of EasyBuild. Now let's take a look at Spack as well. So Spack is in some sense very similar to EasyBuild. We call EasyBuild a tool to install software, and Spack, they say, we're a package managers for supercomputers. It's all potato to some extent. Spack is a little bit newer, so it was created about 5 years after EasyBuild was created. But from a high level, it really does the same thing. It automates the installation of software, typically from source. Spack also has pre-built packages that it can install if it matches your CPU and your operating system. It can generate environment modules for you. It doesn't do it by default. I think you have to tell it. So there's some small differences left and right. Now, one key difference, and I think that will show in the demo as well, is the main intended use case of Spack. Spack is more oriented towards developers of software who want to quickly juggle different dependencies, change the MPI version, use a different compiler, and play with all these options. And it's very flexible for doing so. That's less the case for EasyBuild. And EasyBuild, everything is hard-coded and specific versions of things, while Spack is a bit on the other end of the spectrum. So let's see how we can use this. First of all, we'll have to install and configure Spack. Installing Spack is already a bit weird, at least to me. I told you I was going to be very neutral. To install Spack, you clone the GitHub repository, so the Git repository, which means you get the latest development version, at least by default. Now, they do tagged version as well. You can check out the specific version if you want to, but this already gives you more like developer kind of feel to this. Once you've done that clone, you can set up your environment for using Spack by sourcing a script. It gives you a Spack command, and then you can start installing things. Typically, the first thing you do with Spack is you tell it to go find compilers, because it needs a compiler to start with to then install maybe a compiler or something else. So you typically do a Spack compiler find, and by doing so, it will become available of the system, become aware of the system compilers, and then you can start installing things. Once all of that is done, let's take a look at how we can install TB Lite. So similar to EasyBuild, Spack has subcommands to explore what packages it knows about, what software it knows about, to get information on this, to get a dependency graph. And once you're happy with all of that, you can tell Spack to install a particular software package. And rather than using something like a recipe in easyconfig file, you typically just specify on the command line what you want. So here we say we want a particular version of TB Lite, so we do add 040. And we also want the Python binding, so we do plus Python. So we enable the Python variant that Spack knows about. To make it really equivalent to what we did with EasyBuild, you would actually do a two-step process. You would first install a GCC 13 compiler, and then tell Spack to use that compiler to install TB Lite with. So by default, it will just use the system compiler, which is typically an older GCC. Now, once that is done, you can check what is installed with Spack find, and you can load particular software to use with Spack load. All right, so let's do a very quick demo of that as well. Let me actually make sure I have a clean environment here and check what I have done already. So here I have Spack already pre-cloned. So I'll keep this because this also has a bunch of pre-installed software already. So here in Spack opt, you'll find a bunch of existing software that was pre-installed. So all of these things here are packages that I installed a couple of hours ago, which are essentially the dependencies that we need for TB Lite, but TB Lite itself is not in here. I'm doing this because otherwise it would take too long to install everything from scratch. So we're gonna set up the environment, make sure I don't mess this up. So we source that script, And now we have a Spack command available that we can run. And as you can tell here, we're not using a proper release of Spack, but just the latest development version. So let's see if things work, but hopefully they will. First step is typically to do a Spack compiler find. Now I did this earlier, so it's just going to find what was cached, which is hopefully a bit quicker. What Spack compiler find really does, it generates this file in your home directory called the packages.yaml file, and it will just contain what GCC system compiler is available and what the commands for that are. All right, if happy with that, you can change this if you want to. If there's maybe additional compilers that you want to use that you know are there, you can edit this file manually. But for now, we're happy with this. We'll take a look at Spack list. So we're interested in installing TB Lite. Does Spack know about TB Lite? And I'm doing this on the data file system, which is probably not the best option, but okay. At least not in terms of the speed of installing things. We can ask Spack what it thinks about dependencies for TB Lite. So this has a fancy, colorful output that tries to represent the dependency graph, which is hopefully not going to take too long. And once we're happy with that, we'll do a Spack install here of a particular version of TB Lite. Yeah, so this is the dependency graph. You can see it really tries very hard to make sense out of this with different colors, but okay. Yeah, it's a bit big, so it's of course difficult to do this. Now, let me make sure I don't mess this up. Yeah, okay. So now I'm going to tell Spack to install TB Lite with Python bindings. And it should be able to find all the dependencies already. So it's only going to install TB Lite itself. So that should be rather quick. And then when it completes an installation, we should be able to Spack load and get a working TB Lite installation. So let's see, it should kick off pretty quickly. So it's now essentially scanning all the packages that it knows about already. It can find all the dependencies here, and now it's installing TB Lite itself. Now, one thing you'll notice here is that in this particular package for Spack, so the TB Lite package, they're not defining a test step, so they won't be validating the installation before completing it. That's maybe one difference between EasyBuild and Spack, that we do more effort there or pay more attention to those kind of details. That's also why this installation is a bit quicker, because they're skipping parts of what EasyBuild does. Now we can do a Spack load. You can make the load very specific like this, but since we only have a single TB Lite installation, we can just load TB Lite. And now it's setting up our environment to make sure that TB Lite can be used. And if we check which TB Lite we now have active, we'll find the one in the Spack opt directory. And also here we can see the CPU detection to figure out which CPU we're running, and this should be working. Also, the Python bindings should be working to print the TB Lite version. Yeah. So in the end, it feels pretty similar to EasyBuild, but underneath the covers, it's doing things quite differently. All right. So similarities between EasyBuild and Spack, there's quite a lot of them from a high level. They're both implemented in Python. They're both open source. They're both backed by a worldwide community who actively develops and support these tools. They have a strong focus on HPC and so also on performance. You don't need to have any admin privileges, so no root permissions required to install software. You can do this in your VSC account without too much trouble. You can configure these tools quite heavily. They give you a lot of configuration options. I consider both an expert system, so there's a lot of effort and work going into these tools to get the details right. So we're really leveraging the expertise from people who are supposed to know what they're doing. And probably you'll get good installations as a result of that. In both cases, though, it's not a magic solution. So things will still go wrong, especially if you go beyond what was tested by the community. You may run into surprises left and right. There's also a lot of differences. So EasyBuild is definitely mostly European. It was created in Belgium. It's used by a lot of European HPC sites, also in Canada a bit, and some US sites, but it's definitely mostly European. Spack, on the other side, is mostly US-based. Maybe that's also why Spack was created, even though EasyBuild was already there for a while. They wanted to do things differently or in a different context, so they sort of evolved separately. The software license is a bit different. The way you install things are a bit different. EasyBuild mostly focuses on Linux. It, to some extent, works on macOS, but you won't get very far. While Spack also has full support for macOS and even Windows to install software with. The use case is a bit different. I would say EasyBuild is more focused on HPC support teams, while Spack is more focused on making software developers happy. EasyBuild has been stable for a long time, so we try to make sure it doesn't break over time or that you don't run into surprises when you pick up a new version of EasyBuild. Spack has only been stable since this summer, so after about 10 years of development, they've landed on something that they're happy with and that they want to keep stable going forward. And also in terms of features, there's quite a bit of differences if you go beyond the basics. So when should you use those tools? Well, if you want a uniform way of installing software, these are probably the tools you want to look at. Regardless of how the software is installed, whether it's CMake or pip or whatever, you can talk to EasyBuild or talk to Spack and have a uniform way of installing things. It gives you a way to build a consistent software stack, so it looks and feels the same regardless of the software being installed, and they both keep good attention to the performance of that software. It's developed by experienced people, so you can really leverage those efforts, and that's definitely recommended. And they're backed by big communities as well, so you can get help pretty quickly if you're stuck with something or if you have any questions. The downside for both is that they're maybe not that easy to work with initially, or if you don't have a bit of background on compiling software, building software, as soon as you run into problems, you may be stuck, and it may be difficult for you to figure things out, how to go from there. But you can then again leverage the community to get answers to the questions you have.